In this video, we are looking at solving systems of linear equations, specifically looking at how to do this graphically or using graphing. So when we have a problem like this, 2a plus 5 equals 10, and we're trying to solve the linear equation, what that means is we're trying to figure out what value would go for a in order for this equation to make sense. And there's only one answer here. There's only one number that a can be in order to make that sentence make sense. When we have an equation like this, y equals x minus 3, then we have lots of different answers for y and x. We're looking for pairs of numbers, a 1y and an x, that will match together in order to make that sentence make sense. And so when you're graphing, maybe you're doing a table of values, and you're looking for pairs of numbers that I can put in for x and y in order for this sentence to make sense. However, if we're given two equations, like y equals x minus 3 and y equals negative 2x plus 1, what they're asking is what pair of numbers, what x and what y, would work in both equations. And in this case, for linear equations, so for straight lines, there's only one. There's only one pair of numbers that would work in both. And there's lots of different ways to figure this out and what this means. Graphically, if we were to graph these equations, again, they're straight lines, that means that for the x and y to work or be the same in both equations, that's where those lines are going to intersect, or where those lines are going to cross on a graph. So in order to solve these graphically or using graphing, what we're going to do is graph both lines and then see where they intersect. Now the kind of downside to doing it graphically is you kind of need them to cross at a nice point. If they don't cross at a nice whole number, then you're going to basically have to guess or estimate what that answer would be. And in that case, graphing probably isn't your best bet. You're going to want to resort to another method. But let's look at some examples. So solve the system of equations gives us two lines. Again, what they're asking is what x and y would work in both. And so we're going to look at solving these or graphing these equations and seeing where they cross. So for this, you are welcome to graph in whichever way you like. You can use a table of values, you can use x, y intercepts, or there's another method you can use, which is to use the slope and the y-intercept. So remember, when an equation is written in the form y equals mx plus b, we know that m is our slope and b is where our line crosses the y-axis. So in the equation 2 minus 2x, this is telling me my slope in this case is negative 2, because negative 2 is in front of our x, and our y-intercept is 2. Okay, so I have negative 2 and 2. So if I look at where it crosses the y-axis, it crosses the y-axis at 2, and it has a slope of negative 2, meaning that I'm going to go down 2 over 1. So a slope of negative 2, we can think of this as negative 2 over 1, which means 2 down and 1 to the right. We always go to the right. Okay? The negative sign tells us to go down. So I'm going to go 2 down and 1 over. 2 down, 1 over, 2 down, 1 over, and you can see sort of my line forming based off of those two bits of information. So again, you can use a table of values, you can use x, y intercepts. I'm going to use the equation itself in order to graph this. Then I'm going to take a ruler, and I'm going to make a nice straight line, and you want to graph this as accurately as you can. So let's look at our next equation, y equals x plus 5. In this one, my slope is going to be 1 because I have no number in front of my x. We can see it as a 1. And then I have a y-intercept of 5. So I'm going to go to my y-intercept first, which is at 5. And a slope of 1, again, we can see this as 1 over 1, which is telling me 1 up because it's positive, and 1 to the right. So I'm going to continue to follow that pattern in order to draw my line. And trying to be as accurate as we can. And then we can see that our lines cross right here, which is the point -1, 4. So therefore, x is -1 and y is 4. And we can check our answer here. The nice thing about these questions is we can always check our answer. So let's do a quick check. To check, we're going to substitute -1, 4 into both equations, and it should work out in both equations. So y equals 2 minus 2x. 4 equals 2 minus 2 -1. So we're checking that the left side equals the right side. So 4 equals 2 plus 2, 4 equals 4. Check, so it works in the first equation. Let's check the second equation. And we want 4 should be -1 plus 5, which it is. Check. So if it works out in both equations, you know that we've done it right. Okay, let's try this one. Here is your 2 equations. Now they're not in y equals mx plus b form, but you can rearrange them in order to use that method. So what I'd like you to do is graph these 2 lines and then see where they cross in order to solve the system of equations. So pause the video, try it out, and then start it up again when you're ready. Okay, so again, I like to use my y equals mx plus b equation in order to graph. So I'm going to rearrange these and see if they give me some nice numbers to work with when graphing. So I get 4y minus 3x equals 0. I'm going to solve this to be y equals. So I'm going to add 3x to both sides. It gives me 4y equals 3x. And then I'm going to divide by 4, and I get y equals 3/4 x. So what this tells me is my slope is 3 over 4, which means 3 up and 4 to the right. And you'll notice it doesn't have a plus or minus something, which tells me my y-intercept is at 0. Okay, so I have a 0, 0, and then I'm going to go up 3, 1, 2, 3, and over 4. And I'm following that pattern in order to get some points to graph my line. And I'm trying to be as accurate as possible. And I'm going to label this line so I know which one it is. And then I'm going to repeat that process with my next line. So my next line is 2y minus 3x equals 6, or 2y equals 6 plus 3x. I'm going to divide by 2. So that tells me my slope is 3 over 2, which means 3 up and 2 to the right. And my y-intercept is 3. So I'm going to go to 3, and then go 3 up, 2 over, and then go backwards in order to go down the other side so I can have a couple points to graph. Again, we're trying to be as accurate as possible. And I see that my lines cross right at this point here, which is -4, -3. So x is -4 and y is -3. And again, we're going to do a quick check just to make sure that I've done that properly by substituting those values into my original equations. I'm not going to use the equations that I rearranged just in case I made a mistake while rearranging. I'm going to go back to the original equations and substitute in my numbers and just make sure that my left-hand side equals my right-hand side. So you get -12 plus 12 equals 0, or 0 equals 0. So it worked in that first one. And then I have 2, -3 minus 3, -4 should equal 6. I get -6 plus 12 equals 6, or 6 equals 6. So I know I did it right. So my answer is x equals -4 and y equals -3. Okay, let's take a look at this one. So I have the equation y equals x minus 2. So my slope is 1. Again, remember that's the same as 1 over 1, or we can say 1 up and 1 to the right. And my y-intercept is -2. So I'm going to start at -2. And I'm going to go 1 up, 1 over, 1 up, 1 over in order to graph my line. I'm going to label it. And then my next equation is y equals x minus 3. My slope is 1. And my y-intercept is -3. So I'm going to put a -3 and go 1 up, 1 over, 1 up, 1 over. And maybe some of you are already seeing a problem arise. We don't have any cross on our graph. Now, if I was to extend this graph out and I extended it more and more and more, would it eventually cross? Like maybe they just don't cross in the graph that I have drawn. No, because if you'll notice, they both have the same slope. What do we call lines that have the same slope? We call them parallel. They are parallel lines. So if they never cross, what's our solution? Is there an x and y that will work in both equations if they never cross? No. So we say here that there is no solution. So if they have the same slope and they're not the same line, because you could also have it where they're, the same line. They're not the same line. They're different lines. But they're parallel, so they'll never cross. So therefore, there is no solution. Okay, let's look at this one. My first equation is 2x plus 4 equals y. So that means my slope is 2 and my y-intercept is 4. So let's start at 4. I'm going to go 2 up, 1 over. and so on to graph my line. And let's look at our second line, 4y minus 16 equals 8x. So I get 4y equals 8x plus 16, y equals 2x plus 4. Oh, see, now that I've rearranged, I see that I've ended up with the same line, which means those lines are going to overlap. So the lines are the same. So let's think about this. If they overlap and they're the same line, what is my solution? What x and y will work in both equations? All of them, right? They're the same line. Every x and y that works in one will work in the other. So we say there are infinite solutions. Okay, so if they're parallel and they never cross, there's no solution. But if they're the same line, they overlap, that means we have an infinite number of solutions because every x and y that works in one will work in the other. Okay, so I want you to rate yourself based on how you've felt about this video in solving systems of equations using graphing. I want you to give yourself a thumbs down if you're having some trouble and need some help, a finger pointed if you need some more practice, and a thumbs up if you think, I've got this. I don't need any more help or practice. I know how to solve systems of equations with graphing.